This episode of the UAV Digest is sponsored by GoEngineer, provider of design, engineering, and 3D printing solutions for the aerospace and unmanned vehicles industries. To learn more, visit theuavdigest.com/GoEngineer.
You're listening to UAV Digest, episode 57. I'm David Vanderhoof in Philadelphia, Pennsylvania.
And I'm Max Flight in Hartford, Connecticut.
Hey, Max, we got a great show today. We've got no news, but a great guest.
Yes, David, we're joined by Dr. Ernest Earon. He's the co-founder and president of PrecisionHawk. Now, Ernie holds a PhD in aerospace from the University of Toronto, and he's got over 10 years of experience in the field of unmanned aerial vehicles and intelligent autonomous vehicle control. So, Ernie, we want to welcome you to the UAV Digest.
Oh, thank you. It's great to be here.
Ernie, let's start by grounding everyone and describe what it is that PrecisionHawk does, what they produce.
Did you just say grounding about UAVs?
Oh, sorry.
This isn't the FAA. I'm sorry, I didn't need to interject there, but it just sort of was like, really? That's where you went?
Well, it is an industry that is hard to avoid the puns, like, when things really take off and you got to know whether or not ideas are going to fly. It can be difficult. It's true. Really, PrecisionHawk occupies a brand new space in what is already a very transformative industry. We don't really consider ourselves a drone company. That's one of the key things that matters to us. We are an information company, and that goes far beyond the aircraft. What we do is we provide the tools that support better decision making. That's where we live.
And give us some example of what those tools encompass.
Sure. So we certainly do produce an aircraft as a method to collect data, but it's important to know that our platform is not our product. Our product is the information delivery. So we've built an entire information pipeline that takes data either from an aircraft or the UAV. But that's not enough. That's never enough for our customers. So all the work that we do and the tools that we have put in place, they're all designed to close the gap between that collected data and usable information delivered to the right place. Because let's face it, information isn't useful unless it's in the right person's hand at the right time.
Sure.
Just to touch on the UAV, most of what we talk about on the show is quadcopters, octocopters, yet you've settled on a fixed-wing aircraft, and you actually call it a system. I agreed that you've said that it's about information, so it's part of a system and the sensors, etc. But how did you decide on fixed-wing over multicopter?
When we were first looking at the applications and the solutions we were trying to solve, the fixed wing just worked out well. Our original focus, interestingly enough, was on pest control in vineyards. And for that application, we needed to have a system that could stay in the air as long as possible. We'd dress it up so it would look like a hawk, fly like a hawk, and keep the birds out, because birds will strip a vineyard bare, and usually about the day before you go to harvest the grapes. And then the idea being that once we're up there flying over top of these crops, well, why don't we start collecting some information, some status information on the health of the crop? And then we can give that back to the farmer as a subscription. Once we started looking at, that data and that informatics piece, the demand from general agriculture really overwhelmed the activity in viticulture, and we've been, doing our best to keep up with that excitement ever since.
And we've been talking about you lately in relationship to the UAS test site, the New Air test site. And maybe you can tell us something about how that's come about and what the goals and objectives are.
For the New York test site?
Yes.
Yeah, that's actually something that's very exciting. We're very pleased to be a part of that. We've been talking with Cornell for quite some time. We've been working with them. Obviously, they have a big interest in doing agricultural research, and they reached out to the New York test site as a means to get a COA to operate. And so we were very happy to support that and to work with them to make sure that they were able to operate and do the research that they wanted to do, which is a little bit different than most COAs that have been issued to date, because the main focus of this one was on a real application, an end use application, that of agricultural research being flown by agriculturalists and agronomists and researchers, as opposed to engineers and pilots. And that's something that's really sort of at the core of what we're trying to do. And of course, the benefit of this is that it allows the FAA to get very useful information on what an end use application looks like. So it's not just a pilot flying around, but what does it look like? What are the operational features of an agricultural application, so that they can start to construct and build those guidelines around the end use, as opposed to having those built for the manufacturers.
Sure.
What really matters is the end users and the guidelines for the end users.
Ernie, one of the things that I failed to appreciate when the 6 test site concept was initially introduced by the FAA was that they were going to be driven by these COAs to COAs to such an extent. In other words, the scope of the activities at these 6 test sites seems really well defined by the FAA and maybe kind of limited to the scope of the COAs. Are we operating under a really constrained environment here, do you think?
Well, we are operating under a very well-defined environment, yes. And I think that is a good thing, because it is early days, and I think having users who have a very clearly defined scope and a very clearly defined project makes it much easier for the FAA to feel comfortable about what's going on. We've been operating globally for some time. Up in Canada, we've been flying for many years with authorization from Transport Canada. We've also been operating in the UK, certified there, and we're looking at moving into Australia and South America. And all of these regulations sort of globally seem to be coming to a consensus on this. And right now, for a lot of those operations, you do want to have a very well-defined scope, because it just makes it easier in the absence of a very, very prescribed framework. It allows the regulators it allows them to be able to say, yes, we are comfortable with this activity.
Sure. And if you gave them something sort of open-ended and broad, it would be difficult for them to say that.
Absolutely. I mean, if you were just to say, I want to go fly an airplane,
yeah,
and that's it, well, that's very hard for them to say, well, are you doing this responsibly? Are you doing this safely? As opposed to, our customers and the work that we do, where you're saying we are flying above agricultural fields during daylight hours, line of sight. It allows the FAA to say, okay, well, that is a very low-risk activity.
Interesting.
So, Ernie, I guess the next question is, what exactly the data are you pulling as you fly over viniculture, being a wine drinker and knowing the area in which you live, which makes some really good wine? How would
very good ice wine, yes.
Yes. So what are you focusing on? What is a farmer out in the Midwest here in the United States who gets a PrecisionHawk and starts flying it over his crops? What kind of data is he gathering? What's the takeaway, and then how does he apply it?
You know what? I think there are 2 sort of key things that these systems enable people to do. One of which is to address problems early on where they're still manageable before things get out of control. And in there's lots of examples of that. Agriculture is one of them. You stop some sort of pathogen or some stress that is moving through the field. You can address it early before it becomes a problem over an entire crop. Actually, a great example for that I like, because it illustrates the thing really well, is something like a dead zone in the Gulf of Mexico caused by industrial runoff. In that case, you might say, well, how can a small 3-pound airplane that you hand launch possibly help you deal with hundreds of square miles of ocean? And it does that by giving you very on-demand, very precise monitoring of wetlands and watersheds and rivers and streams before they get to the Gulf. So you can be looking for the sources of these problems early on. You address them when things are small. It's like going to a doctor when you've got a cough rather than waiting till you've got full-blown pneumonia. And the same thing goes with agriculture as well, as I said. The other thing that is very, very valuable for these kinds of platforms is that it gives you a whole new way to look at your problem. The example that I really like is that of a farmer who has just had a massive hailstorm, go through the area. And the farmer is standing there next to a field of mature corn and an insurance representative. And between the two of them, they have to come to some sort of agreement as to how much of that crop to claim. Now, walking through a mature cornfield, trying to get an idea of how much of your field has been damaged is an incredibly labor-intensive process and very difficult to do. As opposed to just saying, well, let's throw this airplane, the aircraft takes off, it does everything that it needs to do to get you the information that you need. It does all the flight planning, everything for itself, and comes back and lands. And you can start looking at that whole big picture view of your field right away. And so that's a very good example of a viewpoint that you just can't get any other way, where it's got to be done now because that insurance rep has got a lot of fields to cover, and you're only going to get one chance.
Ernie, you've been involved in unmanned vehicles for quite a long time, and you've really been involved in some quite interesting projects along the way. Maybe you could tell our audience about a few of those and maybe how they've kind of positioned you for what you're doing currently.
Sure, I'd be happy to. So my background actually was originally in space robotics for planetary exploration. And so a lot of the work that I've done in the past has been putting lots of intelligence onto the robots, the machines, the systems that are out there. Because, you can't just drive a robot around under RC control when it's on Mars.
Right.
And so you had to put enough intelligence on the platform to allow it to do its job. And that's very applicable here on Earth, too, because, well, there are things that machines are good at, and there are things that people are good at, and they're not the same things. And so the idea being that computers are great for doing the same thing over and over again, being very precise, being very methodical, and calculating the flight plan to get an optimal view of a field. Humans are great at looking at that data and having a context and understanding what to do now. Once you've got that information in your hand, that map of your stress in your field and saying, well, what's my next step? Humans are great at that. And so a lot of the work that I did really focused on putting the intelligence in the machines and let them do their job to free up the people who are looking at that information and let them do their job. There's no reason that at this day and age, a human being needs to be flying an aircraft.
And so it kind of comes down to a software issue, doesn't it? A control software issue?
Absolutely. That's why for us, we sort of come back to the fact that, we don't consider ourselves to be a drone company. It's an information company. And a lot of the work that we do is putting the intelligence into the platform to make it the best possible platform for collecting data. Because let's face it, no matter how good your back end is, no matter how good the analysis software you have is, if you don't get data right the first time, there's not a whole lot you can do with it.
Sure, absolutely. Well, there are a lot of companies around these days or entrepreneurs who have visions of creating companies in this space, broadly unmanned aerial vehicles and systems. But it's difficult for many to kind of get started or to kind of proceed with a business plan, given that we have, in the United States anyway, so much uncertainty about what the regulations will end up being. So what kind of challenges does that present to PrecisionHawk? And do you have any advice for others who would like to get into this business? Challenges as to that the regulations are sort of putting on us as a company and people who want to get into this space? Yeah, the fact that we just talked last episode about some farmers that got together with the University of Maryland and had some conversations about using UAVs for precision agriculture. And some of the farmers were kind of reluctant, and some of the others were kind of reluctant to get too deep into it too fast because we don't have the regulations in place from the FAA. So that makes it tough to run a business, when it's like running an airline without the FAA yet having the regulations that apply to airlines. Yes,
that is definitely true. First off, I would say it is possible to operate now. I mean, the FAA does grant permission for certain uses and for certain institutions, and we work with a lot of those. One thing that we do have going for us is that we have a very large global footprint. And so we're able to operate outside the U.S. Now, we are certainly very much looking forward to when the space does open up in the U.S. because the market in the U.S. is, of course, massive. So that is something that's very important to us, as well as making sure that we do the right thing. I mean, we're very proud of the track record we have with regulatory agencies around the world. I think for entrepreneurs and people getting started in this space, you're right. It is difficult now to sort of try and put out your shingle right now and say, I'm going to be doing this, because the FAA has really said, no, hold on, we've got to put the things in place to make sure that this is going to work as an integrated environment. So that does make life difficult. But from the point of view of sort of any entrepreneur, somebody looking into this space, what you do have to look for is what that timing is going to be, and to look at what problems exist and focus on that as opposed to focusing on, I want to use UAVs. Because it's a slightly subtle difference.
Yeah, but it is a significant difference.
It is. It makes a big difference in sort of the mindset going forward, right? Because you're not necessarily focusing on, if I want to be a farmer, do I want to fly UAVs, or do I want to be a farmer who's solving agricultural problems? And there are ways that you can, learn and use this opportunity right now. And this is something that we're very interested in doing, and something we're really looking forward to or continue to push forward on, is taking this opportunity to make sure that what we are doing fits in with the guidelines as they are now and what they're going to be moving forward. And that means, providing input and feedback whenever the opportunity presents itself, and the New York test site is a great example of that for us. It allows us to make sure everything that we have in place works now and works going forward, so that when the FAA does say, here are the regulations and the guidelines for commercial civil use, we already have that stuff in place. So it's a great opportunity now to be looking forward as opposed to sort of looking right now.
You talk about your international footprint, your global footprint. What have been your takeaways from working in Canadian aerospace and UK aerospace? What have they brought to your table? And maybe there were some surprises or something that you can use to leverage as we go forward here in the United States with the FAA.
I think one of the things that has struck me personally is that there are different processes and there are different routes to go through the certification. But one, the end result is the same. All these regulators are looking to try and understand and make sure that these systems are operating in a way that is safe for the entire, for all users of the airspace. That's one. The other thing that is very important is history and precedent, because it's incredibly valuable. For instance, when we went to the UK and we approached the civil aviation authorities there and said, this is what we want to do. And we were able to bring to the table with them 6 or 7 years of operations under certificates from Transport Canada for legal operations there. And they were able to look and go through all of our documentation that we had built up over that time. And I think the same thing is going to happen with all regulators because, let's face it, this is a very new space. It's a very transformative space. And so there's a lot of uncertainty. And being able to help relieve some of that uncertainty by saying, we have this background, we've been doing this, we have demonstrated safe operation, has been invaluable for us going forward and for the regulators, reviewing those applications. Another thing that is very interesting is, and I mentioned this before, the world does seem to be coalescing, if I can use that word, to a fairly common set of guidelines as to how this process is going to happen. And that's a very good thing, too, because there's a wealth of information on how systems can be integrated in other airspaces successfully. And I know that, all of these different groups are looking at that and trying to tailor those for their own applications.
One thing we worry about is the bad boys, if you will, the folks that get out there and do something, well, stupid, I'll say. Yeah, but in some cases, it's just because of lack of awareness and because these people haven't been in aviation or haven't been pilots or any of that sort of thing. So they're just not aware. But in any event, they do something stupid. It's great material for the press. And so it starts to project an image of sort of irresponsibility and that we worry that will lead to some regulations or laws in ways that are not really productive for the industry. Do you think that's a real danger, Ernie?
Absolutely. I completely agree that, let's face it, we're very excited about this opportunity, about this technology, and about this space. And we want that to keep moving forward. There's a lot of momentum. There's a lot of excitement. And we want to keep building that because the benefits are huge. And as you say, when somebody goes out and does something that detracts from that, either in people's perception or by doing things that are irresponsible and reckless, it destroys that or slows that process down. In the best cases, slows that process down. In the worst case, it can cause real problems. So yes, I think also as you guys correctly pointed out, the bad use cases get all the press. One thing that we see all the time, in the space that we're working on, we see all the good news cases. We see the value that this technology can bring to end users. We see how, you can sort of boil it down in agriculture to helping farmers feed a very hungry world. And in a world with, high input costs and hugely varying climate, you have to have these tools. And so we see how there's that benefit and it can help that way. But of course, the public is bombarded with those bad news images, privacy concerns, and people doing crazy things like flying down streets of New York City. In a lot of cases, what I think we need to do, and it's something that UAV Digest is doing, and I think it's incredibly important, is to try and show the general public that the good use cases outnumber the bad.
Yes.
That this technology, has the potential to really transform the way the world works. And the only way to do that is to educate people, because I think once you do that, once people see that the benefits of this technology are so big, I think the reaction is going to be positive. I can't see how it couldn't be positive when you see what the potential is. So definitely something that I think as an industry, as a company, personally, I think we all need to do is to really make people aware of the benefits and the good use cases, because they really do outnumber the bad.
So if you polish up your crystal ball and look into the future for this industry, what do you see? What do you anticipate? So again with my little crystal ball gazing here, I actually foresee that this technology is going to become incredibly commonplace. I liken it to cell phones, right? Right now, you look at the world and everybody's got a cell phone and they're all standing around like, how did I live without this piece of technology? Right.
I think drones are going to be very much like that, because they're a great opportunity to network the existing pieces of these industries together. It brings new ways of looking at the world. It brings new information, and for companies, and more of them are looking at this more, increasingly every day. The value of the information on what is happening, in their space, in their production, whatever, plays a huge role in the decision making that they do day to day. And as that continues to ramp up and go forward faster and faster and faster, and you've got this great tool, I think it's not going to be long before they're going to be saying, how did I ever get by without this unmanned aircraft providing me with this information right from the get-go? And in fact, what I think is going to happen before too long, certainly in the agricultural space, is that this data, and I'm calling it data very specifically, the data coming off the plane is going to be sucked into the analytical systems. It's going to be processed, and then the information is going to be fed right into the farm machinery, the sprayers, the planters, the harvesters, without humans ever having to look at it. And so it's going to close that loop completely contained and just help to drive that efficiency, that ability to do more with less, which is really a requirement in today's age.
Okay, I'm going to go a little bit down the dark side on here then. On Airplane Geeks, our other show, we've talked about information overload. Do you think that you talk about floods of information, do you think we might get to a point with this technology that we will be getting too much information?
Too much information.
Too much data that you start not being able to interpret what you're getting.
Oh, okay. Well, that is certainly an interesting feature right now in particular, because the volumes of information, the volumes of storage that is required is actually really high. So yes, that is an interesting side effect. But I think the other thing that is happening is the more we collect this information, the more we analyze this data, the more value that we see in it, the more we're going to use of it. So this is going to, eventually I see that this is not just going to improve a specific farmer's production in a specific field, but this is going to start to provide value to stakeholders across the industry. Everything from, like I said, from the individual farmers to an entire county so that they can share information, for instance, on what pests or pathogens are going through, to the insurance industry to be able to help farmers make sure they've got the right coverage based on what's actually happening on the ground. So I think the information that we're collecting is going to continue to grow, and I think it's going to become a challenge to process it and present it in a meaningful way. So in that case, absolutely, that is something. It's something that we are devoting a considerable amount of effort into, because for us, that is what matters, and that's what our customers need to see. So we take this this flood of information, and we have to make it interpretable and usable in a way that somebody can just look at it and say, okay, this is the way we're going to go forward on. Because if it was just a case of handing a farmer 3 gigabytes of imagery taken over his field on any given day, that's almost impossible to do anything with. So you're right in that we do have to be concerned about this, certainly. And the way to do it is to turn that data into usable information that they're able to process and do something with. And
so that's, I guess, what the Lancaster platform is all about, right? Is creating a platform that can contain the sensors that allow the collection of the data that's relevant to the application at hand. Is that a way to characterize it?
It is, and even more importantly, making sure you get it. Because if you've got the data collected properly, that is what frees up this huge potential to do the analytics, to process it. And we do our processing. All this information goes up into the cloud and gets processed there, and allows different stakeholders from different places to look at it. But as we've talked about, it's critical that you get that right at the beginning, at the start of the data pipeline, which is where the sensors sit. Because if you don't do that, there's not much value that you can extract from this stuff. So, you're absolutely right. The platform is the means to get the best data possible.
Ernie, where can we find more about PrecisionHawk?
You can always find out about more of what we're doing on our website at PrecisionHawk.com. You can also find out information directly from our Twitter feed at PrecisionHawk and on Instagram.
Right, Dr. Ernest Earon, thank you so much for spending a little bit of time with us. I know we could talk for quite a long time. We could probably talk for hours about these things because it's such an exciting time in this industry. The employees at PrecisionHawk, do they feel like they're in the beginning of something great? I mean, is there that kind of energy at the company?
Yes. I consider it to be one of the best parts of my job is to be able to work with the team because there's so much enthusiasm, there's so much drive. It's incredibly, it's catchy. It's
sure.
You walk in and people are doing new things and they're producing and they're so excited to be part of this industry because they recognize that there is such incredible value going forward and they want to do that. Our employees, they want to make the world a better place, and they see this as one of the ways that they can do that. And we've got an incredible team. I travel all over the place, and I talk about what it is. And one of the things that people come out is like, and say to me, they say, "Wow, I didn't even know that was possible." And I got to tell you, one of the most exciting things is knowing that I have a team, or that I'm part of a team that not only can make it possible, but they can make it user-friendly because it still has to be, absorbable by the user. And it's hard not to get excited to get up in the morning with a team like that.
And it doesn't get much better than that, for your job. So that's great. And I think a lot of people are also finding this to be sort of an infectious time in that regard, and they're looking for ways that they can get into this business in one form or another. Some people are interested in manufacturers making drones, as it were. Others in different applications or providing services. It's just a huge industry potential, I think. And there any advice for folks who are kind of looking around for how do I personally get involved in this or make a career change in order to get involved in this? I guess from my perspective, one of the things that I think is incredibly valuable is people who have a broad view, right? It's not just about people who understand aerodynamics or understand programming for control, because this is an industry where any single piece that you touch, whether it's a wing or whether it's a power circuit, directly impacts everything else on the system. And so having people who have that broad knowledge is very, very valuable. Nobody can work inside a box here because everything you touch affects everybody else. There are a lot of good programs out there. Indiana State has a great program, and schools like that are doing a great job in training people up. I think, again, just sort of coming at it with a passion and a broad viewpoint and a willingness to accept that broad viewpoint, I think is really valuable. All right, Ernie, again, thank you so much.
Yeah,
thanks. It's been a pleasure.
We hope you'll come back and keep us posted. Over the last year, I got to say that I really discovered that I really like the people as well as the technology. And again, you're putting a great face on and a positive face on technology that when Max and I started, one of the reasons why we started this was it seemed to keep getting a bad rap, and there had to have been more there too. So thanks for putting a good foot forward and a good face forward, and we hope you come back.
Absolutely, and thank you for helping to get the good word out there as well. I can talk in a room all by myself all I like, but you guys are the people that can get that message out, and it's really important.
All right, you've been listening to episode 57 of the UAV Digest. You can find us at theuavdigest.com, or you can go straight to the show notes for this episode by going to the uavdigest.com/57.
And of course, you can always find us on iTunes or Stitcher. And if you want to leave us some feedback, the address is feedback@theuavdigest.com. And don't forget to follow us on Facebook at Facebook/UAV Digest. And of course, on Twitter at UAV Digest. So with that, Max, I guess we should say goodbye for another week. And again, we'd like to thank our guest, Dr. Ernest Earon. We really appreciate you being on the show. And with that note, this is David in Philly.
And Max in Hartford.
And thanks for listening.
This episode has been sponsored by UAV Propulsion Tech. a provider of propulsion, servo, and rescue and recovery parachute solutions for the unmanned aerial vehicle market. For more information, check out www.uavpropulsiontech.com.